Okay, log graphs is the first example. What we've got here is data on a cup of coffee. So unfortunately, because we're using both time and temperature, they're both T's. So I'm using lowercase t2 in minutes. It's how many minutes after the cup of coffee was poured. And then big T here is going to be measured in degrees C. That's the temperature of the coffee. So it starts off hot, it gets cooler as time goes on. Now what we suspect is the form of these is something like this. So T, the temperature, is equal to Ka to the power of small t. Now, if this was a straight line, we'd be able to plot it, read off the gradient and the y-intercept and find the equation of it. This is a variable. It's a bit like we have y in the equation, and this is a variable as well, the other t. They're the things that happen in the table. That's a bit like the x in the equation. K and A are both constants that we want to find. Our tactic here is to use logs to turn this into a straight line. So what we're going to do is we're going to take logs of both sides. Now it doesn't actually matter what sort of log we're going to do. You could do it with natural log if you wanted. I'm going to write just log. Now remember from last week that when I write just log, that means to the power of, base of 10. So log of one side equals log of the other side. Now I'm just going to put that in brackets to make it clear that it's the whole of that side that we've got log of. Right, if I've got log of two things in there, what we could do is use one of our log rules to write that as log of k plus log of the other thing. Because k and a to the t will multiply together, and so we can split them out like this. Right, I've got a power of t here. We can use another log rule to bring that out the front. So this is log k plus t log a. Just going to write the log t in this side as well. So what we've got here is something where we've got a variable on this side. The variable is like log t. And we've got another variable, t, on this side. You can always tell the variables because they're the things which are in the tables here, so t and big T. I'm just going to put some red under them to label what the variables are. This is actually in the form y equals mx plus c, because this thing here is like y. We've got the equals. That thing there is like x, that's our other variable. This is the thing, all of that, which we multiplied by x, so that's like m, just put a little times sign in there. And then that's the thing that we're adding on. Well, that's just a constant. So we've got that thing there. So it's written in a bit of a weird order, but we've got something which should be a straight line. What that suggests is if we plot it some sort of graph with this axis as the equivalent to the x, so this is going to be the t-axis, I'm just reading off whatever was x, and this axis is going to be the log big T axis, because that's the equivalent to the y. What we should get is some sort of straight line, probably looking a bit like that, where the gradient of it will be log a, and the y-intercept, wherever it crosses here, will be c. Now, I'm going to do this on the computer. Normally in the exam, they will give you some graph paper to do this on. I trust that you don't have graph paper at home, so let's do it in digital format.